Hello, my name is Ryan Swartz, and for my AP Chem project, I will be discussing fuel cells and rechargeable batteries along with the career in biochemistry. A fuel cell is a device that uses the chemical energy of hydrogen or another fuel to cleanly and efficiently produce electricity. If hydrogen is its source of fuel, the only products are electricity, water, and heat. The uniqueness of a fuel cell comes in its variety of uses from powering turbines to laptops and its unlimited energy it can offer if provided enough fuel. Rechargeable batteries are batteries that can be used again and again. And this causes a reduced waste and allows for the consumer to get more bang for their buck out of batteries. In use, the batteries work the same as conventional ones, but once their charger has been used in powering a device, the batteries can be hooked up to a charger to recharge the battery. First, we will just start by discussing fuel cells. Chemicals/elements involved in a hydrogen-oxygen cell is a porous inert carbon anode and cathode with a catalyst that is platinum. Then in the cell, hydrogen and oxygen, which fill the cell, are allowed to flow freely. To keep these freely flowing elements allow the electricity to be produced. The chemical reaction for a fuel cell is 2H2 plus O2 leads to 2H2O. The overall reaction involves the oxidation of two hydrogen gas molecules and the reduction of one molecule of oxygen gas. The electron released by the oxidation of hydrogen gas goes directly to an external circuit to be used as electricity. Though fuel cells are extremely environmentally friendly batteries that produce very little emissions and are very powerful, the insufficient quantities of usable hydrogen and its instability means fuel cells aren't used very much in the present day. Some possible uses of fuel cells are to power reliant stores of power to hospitals and automobiles, while also being flexible enough to power mobile devices such as phones and computers. The main concern when using hydrogen-oxygen fuel cells are that hydrogen is not very available in the raw form that is used in the cell. So we must mine it or we must create it by using fuel cells. By using fossil fuels, and this is not very efficient for the environment since it produces much CO2. Also, hydrogen is not very safe, for it is very unstable in the form that is used in the fuel cell. The next battery we would talk about is rechargeable batteries. The main one is a lithium-ion battery, which is made up of a lithium salt dissolved into a solution to make lithium ions. The anode is a carbon graphite, while the cathode is a metal paired with an oxygen to form MO2, with M being either cobalt, manganese, or nickel. The overall rechargeable battery reaction would be LiX-C6 plus MO2 is reversible to 6C plus LiX-MO2. The X depends on the number of lithium ions that you insert into the graphite cathode, while M depends on the elements used to create metal oxide. The lithium inserted in the carbon graphite at the beginning of the reaction is oxidized into lithium ions at the anode, sending electrons into an external circuit. After going through the external circuit, electrons react with the lithium ions and the metal oxide to reduce the lithium, which is then inserted into the metal oxide. On recharge, the reverse of this happens. Where do you see lithium-ion batteries today? Since they are rechargeable and very useful in that case, many people use them in handheld devices such as thermometers, MP3 players, hearing aids, and calculators. The safety and environmental concerns that are considered when using lithium-ion rechargeable batteries are the inherent instability of lithium metal that can cause safety issues. But since lithium-ion batteries use lithium ions and not the lithium metal, the instability of lithium is not usually an issue. The other environmental concerns are the fact that lithium is usually obtained from crushing it out of rock, which is a fossil fuel intensive process. This means that a bunch of greenhouse gases and carbon dioxide is produced in obtaining lithium. Also, the 11 million tons of batteries that are dumped almost every year, and there has not been an effective way to recycle these batteries completed yet. This leads to a possible excess of batteries polluting the earth. This is my bibliography. A biochemist studies the physical and chemical principles of things while also studying biological processes. Biochemists use advanced technology to expand the knowledge of humans as a whole. The most popular area is the field of medicine, which discoveries used advanced such things as drugs or new medical practices. The most prominent chemicals used as a biochemist are the carbon dioxide and water that is converted into glucose, or the breakdown of glucose into carbon dioxide, water, and ATP. This is a very important process to life as a whole. So biochemists spend much time looking at the elements that make this up and trying to figure out how we could improve or learn how to make more of them to sustain longer life. These are not the only elements that biochemists look at either, all right? So anaerobic respiration, C6H12O6, converting to 2C2H5OH plus 2CO2 plus energy is also another common one. Many biochemists want to figure out how to sustain more efficient anaerobic respiration in the lives of humans, since creating it or using anaerobic respiration in our cells is not efficient. Also, biochemists study combustion, which is C3H8 plus 5O2 to 4H2O plus 3CO2 plus energy. Combustion is used in many processes today, especially the usage of fossil fuel converting to energy and electricity. If scientists can find out a more efficient way to combust these elements into the steam we need to create electricity, they can find a way to create better and more efficient electricity. To become a biochemist, one must be educated in the right subjects to make sure they are prepared for this career. Students are suggested to have a bachelor's, master's, or doctorate degree in biochemistry to be accepted into the field. Biochemists work in the hospitals, colleges, or law firms. Biochemists spend their time researching natural chemistry to discover advancements in things such as medicine. In the case of working in a law firm, biochemists are used to prove or disprove scientific cases. This is just a slide to show what you would see maybe in the workplace as being a biochemist. Why choose biochemistry? The salary on average is $93,280, but this is not like that important to me. As long as the job is interesting like biochemistry is, and as changing as the field is, you can see by the fact that you can go into law with it, I will be completely fine with being in this field. The fact that I can diversify into different branches of opportunity makes me just want to do this job instead of being stuck in a job where you can only go one direction. And also, the chemistry behind this industry is interesting to me, and I would rather like to go into the field to learn more about it. And these are the rest of my bibliographies. Thank you for your time.